Also from NASA's website, there's a downloadable PDF which is a simple experiment that you can do. It's aimed at children, to be fair, but as you can see here on this diagram, you get a straw and you pass a piece of string through the straw, I don't know, 5-6 meters long, tie the string off at both ends, attach a balloon to the underside of the straw with some tape and blow the balloon up and let it go. Obviously we know what the results of that will be, but this is going to be the basis of my experiments. NASA seem to advocate balloons on multiple pages as a good analogue for a rocket, so I thought I'd go with it. So Newton's third law in action. So now to the interesting part, because I'm going to demonstrate in this next test that a mass most certainly is required to make a rocket move, or a balloon move in this case. So I'm just going to put up on the screen again the quote that the guy made earlier that I asked you to remember. It doesn't need to be able to push on anything to make it transit, is what he says. So I've taken a piece of paper and I've wrapped it around the rear end of the balloon and taped it top and bottom. So the nozzle is sort of in the curve of the paper there. So when I let go, the air will still escape from the balloon at the same speed. The balloon will deflate as quick as it did without the paper. So according to his quote earlier, this should still move, this should still transit at the same speed, because it's not reliant upon it pushing on anything. It's the mere fact that air is released from the nozzle that provides the reactionary force to propel the balloon. So let's have a look at what happens. So Newton's third law experiment, test 2. Well, that didn't move very far. Let's try another one. So Newton's third law experiment number 3. Newton's third law experiment number 4. Not looking good. Okay, Newton's third law, 5th and final test. Come on, we've got to see some movement. And just to show that there's no restriction whatsoever.